Welcome to Brain Vision.
Next question, we are looking at a red supergiant star. Given that its temperature of the surface is 3000 kelvins and the diameter is 600 times of that of our sun, we want to find what is the number of photons it irradiates, assuming that it just emits at the peak intensity wavelength. Well, what we will first need to do is to find what is the total energy that is being emitted per second. So this is the power. We will need to use the Stefan-Boltzmann's law, where the power is equals to sigma times A, the surface area, applied by the temperature to the power 4. So we know that the Stefan-Boltzmann's constant, the surface area would be taking 4 pi times r square, but this r is actually 600 times the radius of our sun, so we use our radius, 6.96 times 10 power 8. So this is the radius of the sun. Multiply this squared, we square this. Then the temperature we're given is 3000 kelvins, right? So 3000 Kelvin to the power 4. This is the power irradiated. What we need to find next is the energy of each photon. This equals to hc over lambda. And the lambda, we can find what is the peak wavelength based on our Wien's displacement law. Right? Wien's displacement law basically states that the peak wavelength is equals to some constant divided by the temperature. So this is just hc times the temperature divided by the constant, which is 2.9 times 10 power minus 3. So the temperature over here is 3000 kelvins. Right, so therefore the total number of photons emitted per second, just take the power divided by the energy of each photon. Okay, so put all the expression, we evaluate this in the calculator, take this divided by this, should get 5.0 times 10 to the power of 49 photons per second. Now to find the ratio of the power irradiated by the star compared to our sun, we are given that the sun's temperature is 5800 kelvins. So we know the power is related to sigma A T to the power 4. So the power of the star divided by power of our sun is just 4 pi radius of the star square times t to the power 4 divided by 4 pi r radius of the sun square t to the power 4 of the sun. Of course, we can get rid of the 4 pi. Radius of the star, we have previously mentioned that this is about 600 times of our sun. So if we square this, it will be 600 square. Temperature of the star is 3000 kelvins, 3000 to the power 4. Temperature of our sun is 5800 to the power 4. Right, so taking this ratio, we should get about 3 times 10 to the power of 4. Right, therefore the star actually radiates about 30,000 as much energy per second compared to our sun.